Yeah.
Minore altre supini et Spiritus Sancti. Amen. Confidium Deum et vos Creationis, cogitatione, verbo, opere, et missione. Mecum, et maxima, et io precordias Maria Sancta Virgin. Omnes angelos et sanctos, et vos, patres, orare pro me, ad Dominum nostrum. Amen. In nomine Patris, et Filii, et Spiritus Sancti. Amen.
I like Dave too.
All right, take out your notes, please. For those of you watching at home, hi Alan.
What's up, Alex?
So we are
Belly sneaky smell.
coming back into the derivatives of inverse trig functions. A couple quick things preview. First, two review questions. If I were to give you this, how would you do it?
Oh. Okay, so you want to draw a triangle.
Correct. This is a forward-backward problem. So the way to do these is to draw some sort of trig shape. Again, 95% of the time, you're going to draw a right triangle. So a right triangle. What do you do with the right triangle?
So put theta.
Put theta somewhere. I like putting it on the left, but you can put it wherever you want. Now what?
Tangent is what? To what?
What is tangent? So
Opposite over adjacent.
opposite over adjacent.
So
So what about these numbers?
7 would be the opposite.
7 is the opposite?
3 is adjacent.
3 is the adjacent.
And then
By the way, it doesn't look realistic, but that's because I'm a bad artist, so.
radical
Square root of
58. Yeah.
Yeah, this one, how do you get that so fast?
7 squared plus 3 squared.
Exactly. When you do the big side, the larger side, it's the two small sides squared added together with a square root. So 49 radical 58. Tell me what is cosecant?
That's 1 over sine.
Yes, the reciprocal of sine.
So
Tell me
it's
what the sign would be on this, first of all.
b or
Offset over. Your offset over.
Opposite or hypotenuse. What would that be?
7 over square root of 58.
Yeah, the sine is 7 over radical 58. So what is the cosecant?
1 over 7 over
Thank you.
8. So radical 58 over
It
7.
was, but okay. It's radical 58
over 7.
over 7. You're done. Does that make sense? Oh, she did. Oh, that was nice. There were photocopies for our class that she just dropped off. Oh, that was really super.
Miss Suma is amazing.
Thank you, Miss Suma. You're awesome. Okay.
Yeah.
Now,
I love Alice.
What about
so much.
this?
She's so nice.
I like talking bad about a hoe.
We're gonna talk amazing.
Because it was free to be in this.
Tell her, but Ella's face is shiny.
try that. Never mind.
It's a long story. It's
What?
funny, but it's stupid.
Hey, at least it's not like Caleb's jokes.
Okay, moving on. How would you do this?
All those random people.
Oh wow. Well, you don't know. What was it? Could have been in the denominator.
Yeah, now, this is a fraction. It's 0.1,
Oh.
but that still doesn't help much with the triangle.
It's not a triangle.
It is not a triangle. There's only one other shape you could use. You remember?
Circle.
A line?
What kind of circle? In trig.
Circular.
That's science.
What?
No,
That's a good guess.
Not an eclipse.
No.
A full
There are
circle.
four. Hold on. There are 4 common trig
An
shapes.
oval or something?
Oval, like the ellipses.
A glimpse. His face there is like, what?
Hold on a second.
He's like concerned for us. I'm concerned.
I knew I was wrong when you looked.
There are 4 common trig shapes that we use. In addition to just a generic right triangle, there's the 30, 60, 90
45, 45, 45.
trig triangle,
45,
the 45, 45, 90 triangle. I remember the third. The unit circle,
Oh yeah.
and then the trig rectangle.
Oh, is this the,
In this particular case, we're going to use the circle. Tell me what the unit circle is. It's a circle, obviously.
With the axis and
Where's the center?
1 and 1. Well, it's at 0, 0.
It's at 0, 0, correct. The unit circle is basically the easiest circle to graph ever. So the center is at 0, 0. What else? What's the radius?
1.
1. It's the nicest radius you can have. Where's theta? Is it above or below?
Below.
Below. And does anybody happen to remember these special coordinates for that point?
No,
I can talk you through
I
it.
just talked about it. It's like
It's actually kind of
3 over 3
interesting.
over 2.
We do not know the exact numbers. But,
Wait, it's sine, wait,
what?
sine cosine? Or
Sine theta or
cosine?
cosine theta.
It's cosine of theta, comma, sine of theta. If you ever get stuck and you need to find out which is which, make a little right triangle from that. Now I'm gonna enlarge it. That's this one. What's the hypotenuse?
1.
1. Now I have no idea how far over this is. It's a horizontal unknown. I'm just gonna call it x. And then ditto, ditto, this is gonna be y. All I know is that x is somewhere between 0 and 1. Is that why?
Because 1's the radius.
Yeah. 1's the radius, is as far as you can go. And ditto, y is somewhere between 0 and 1. Does that make sense visually? Okay. So this is x, and this is y, and this is theta. Just for giggles, and this is actually probably what somebody did hundreds of years ago. You just play with this for a second. Just for giggles, try the sine of theta using SOHCAHTOA.
Y over x. Or y over 1.
It's y over 1. By the way, what is y over 1?
Y.
1. You just found y. This point here, you notice it was this far over and this far up? This is x, and this is y. You just found that y is equal to sine of theta. Just by accident. Just for giggles, let's try cosine of theta. X over 1, better known as? You just discovered that x is equal to cosine of theta. That's how they discovered this. Just as an extra bonus, buy one, get one free. What's tangent?
Y over x.
It's y over x. What is that?
Sine over
Look
cosine.
earlier.
Sine over cosine.
It's sine over cosine. Remember that? That's where it came from. And it's also equal to slope. The slope of the radius is the tangent, which is because it's rise over run, y over x. Everybody good with that? Now, why would I bring that up? Well, try this. Can anybody tell me the sine of 150 degrees? And then tell me how you got it.
Let's see. Like,
Excuse me.
radical 2.
Maybe. Tell me how you get it.
I
Okay. Okay. Slow down. Good second.
Did you just
Like
guess?
radical 3 over 2 or something.
Radical 3 over 2 is bigger than radical. Wait,
No, you're getting the right ballpark.
Is it?
Not.
Pi over.
Oh yeah, that's radians.
Wait, what?
Because
These are radians.
sine of 180 is pi.
Well, hold on a second. There are two different things you're talking about. Sine, cosine, and tangent are going to be fractions. They're going to be just answers.
I'm thinking.
When you're thinking pi over 6 and things like that, those are angles. Those are just the exact same. Like pi over 6 is radians is the exact same thing as 30 degrees. You haven't taken the sine of the angle yet. You've just decided whether,
It's like in radians or degrees?
right, whether it's in degrees or radians. It's kind of like if you were in English or metric. It's kind of like saying, well, how tall is so-and-so? He's either, 6'1" or he's like 165 centimeters or whatever, I don't know. Metric well enough to guess. But I can convert it, I suppose. But sine of 150, can I use a triangle to find this? SOHCAHTOA?
Yes. No, I mean.
I cannot.
Circle, I mean. The answer.
Tri theta is 150, what would be wrong with that?
Way too big.
Yeah, way too big. You can only fit 180 degrees inside a triangle. 150 plus 90, kablam. You know, you just shattered a triangle.
But if you change it to 30 degrees.
No,
Where
You
is it?
technically
Where?
could.
30 degrees. It'd be a 90 and a 60.
Okay, this is 30, this is 90, this is 60, true.
Yeah, that's what I meant. 30.
By the way, that shape will come in very handy, but does everybody see that x is, this is going to be kind of stupid, but x is how far left or right you are, and y is how far up or down you are.
Yeah.
On the unit circle, cosine is the left-rightness. Sine is the up-downness. The way you remember this, if you get the two of them, I know I'm making up words. If the way you tell that, what was it? I think it was in college. Somebody finally told me this trick. I was kind of getting those confused because everybody says sine, cosine, tangent. They just figure, well, it's going to be sine and cosine. And I got it mixed up for quite a while. And somebody finally, it was a stupid metaphor, but I love stupid metaphors. It's like, if you put a sign up in the ground, you've got to put it up straight up and down. Otherwise, if you put a sign this way, nobody's going to read it. It's just going to be flat. So the sign has to be up and down.
Yeah,
Yeah,
that's good. I've used that. That's the
Yeah. So, sine of 150 degrees, use the unit circle. Now 150 degrees is here. And sine is the height, right? Let me just draw a little dotted line for the height. Can anybody tell me another location on the circle that's the exact same height?
30 degrees.
30 degrees. I'm going to make the claim that the sine of the height of 150 degrees is equal to the sine of 30 degrees, which is true. So if you can find sine of 30, we're in business. By the way, if you remember your 30, 60, 90 degree triangle, what are the sides for 30, 60, 90? One,
two,
two,
three.
Radical 3. Radical 3 is the medium side. Use SOHCAHTOA on this.
So it's
Hop on the 30 degree angle and do sine.
1/2.
1/2. The height is 1/2. Ditto, ditto. So the sine of 150 is 1/2. I don't know, Mason. And a long time ago, I ran you through a sort of a drill practice thing where I would point to multiples of 30 and I would say, what's the sine, what's the cosine, what's the sine, what's the
I
cosine.
remember that. That's scary.
It was,
It was scary.
now,
Frankly, I don't remember.
on a unit circle, what is sine?
That's the up and down.
Why?
It's the y, the up-downness, if you will. What is cosine?
The left, right.
How far left or right you are. What is tangent? It's the
Slope.
It's the slope. Right. On the unit circle, it is the hypotenuse. The slope on a unit circle. So basically, sine, cosine, and tangent, you can do SOHCAHTOA if you're on a triangle. On the unit circle, they're a little different. Sine is up, down, cosine is left, right, and tangent is the slope. Well, let's go over here. They're asking for the inverse tangent of 0. The tangent of some angle gives you 0. Tangent is slope on the unit circle. Are there any angles on here that would give you a slope of 0?
Yes.
Where?
When it's straight up.
That would actually be
That's not fine.
slope of undefined.
So it's at 0 and 180.
Yeah, 0 degrees, 180 degrees, and technically if you went all the way around,
360.
yeah, coterminal with 360 degrees. So they usually stop short of 360. They just do once around the circle. But the inverse tangent of 0, that's basically saying, can you think of a theta that would give you tangent of theta equals 0? If so, tell me where. There are actually two possibilities. Yeah, 0 degrees or 180 degrees. Find the cosine. You're actually going to get two separate answers.
Yeah, because I mean, it's one negative
What's the
1.
cosine of 0?
1.
It's 1. Everybody see 1?
And
If you go over to the 0 degree position, cosine is how far left or right you are. That's 1.
negative 1.
Done.
5/4.
In other words, you can do the forward-backwards problem using the unit circle as well. The only time I would ever use the unit circle is if you're on one of these, what I call the 4 cardinal points. To the right, top, left, bottom. Those are the ones that don't fit in a triangle. And if the ones are really super huge, that might be true too. But basically the only time I don't use a right triangle for the forward-backward problems is if I have a multiple of 90 degrees, like 0, 90, 180, 270, 360. Those are the ones that just don't work well here. So use the unit circle. Now, a little crash course on how to do forward-backward problem. Drag you kicking and screaming back to calculus. Can somebody talk me through if y equals the inverse sine of x, can you find dy over dx? The derivative. We went over this the other day, but talk me through it from beginning to end.
Oh yeah, so
How do you do this?
do the sine of each side?
Yeah, I cannot take the derivative of this. I have no idea how. But if you get rid of the inverse sine by taking the sine of both sides. Remember, we're taking a function of both sides. We're not multiplying by sine. It's the sine of y. So the sine of y is equal to what?
X.
Yeah, the sine and inverse sine cancel x. Now what? What's our main objective?
To get the derivative?
To get the derivative of this thing.
Okay, so we take the derivative?
Now you take the derivative.
So it'd be cosine.
We learned that when you can do anything you want, no matter how gross to both sides, and the derivative should stay the same.
Yeah, cosine of y dy equals dx.
Yeah, cosine of y dy is equal to dx, or 1 dx. Yeah. Keep going. I want dy over dx. I want to keep dy because I want it on top.
Flip them around, kind of.
Divide by
Divide by
cosine. Just make sure you do it too.
what's that?
Both sides.
And also divide by dx.
And now divide by dx, and that'll cure your problem. Does that make sense? So I'm going to rewrite this. dy over dx, which is exactly what I want, is 1 over cosine of y. So it looks like we're done. Except the original problem didn't have y's in it at all. It had x's in the formula. Can you,
Replace y with
what was y?
sine of negative.
Inverse sine of x. Let me recopy this. So dy over dx equals 1 over cosine of something interesting. Inverse sine of x. That's a forward-backward problem. Do it. But I thought forward-backward problems needed a fraction.
It's x over 1.
It's x over 1. How do you do forward-backward problems? Yeah, set up a right triangle. This doesn't look like a weird multiple of 90. Like if it came up with 0 or something, then yeah, draw a unit circle. But I think a right triangle should work. So how do you do that again? What do you do first?
So, theta.
Yeah, put theta somewhere. And then what do I do with the... Remember, by the way, when you have parentheses inside parentheses, what do you do first?
The inner parentheses.
The inner parentheses first. We're doing this first.
So the inverse sine
Oh,
of x over
X over 1.
That means it's
Where would you put the x? Where would you put the 1? To have it a field sign.
the opposite.
Opposite?
And the hypotenuse. One is.
Hypotenuse. Correct. So we're not doing cosine. We're not there yet. Yeah.
So the inverse sine doesn't affect,
Just drawing this will actually allow you to do the inverse sine in your head, which is kind of nice.
but it doesn't make the hypotenuse on top and the opposite.
Correct,
numbers.
because this is opposite of our hypotenuse.
So the inverse sine doesn't affect that at all. It's still the same.
Correct.
As regular
Right.
sine.
The inverse sine is basically saying, go back and find the theta that did this. If you have like inverse sine of x over 1, they're basically saying, here's another way to write the exact same thing. regular sine of of theta equals x over 1. Find theta. Like, what angle are you using? So it said go backwards and find the opposite over hypotenuse. So ta-da. There's a missing sign.
Yeah, so it's the radical 1 minus x squared.
Right, radical 1 squared minus x squared. Ever see how I got that? When you're finding one of the small sides of a right triangle, you can do that radical trick like we did over yonder, wherever it was. I think I erased it, darn it. But you subtract. You take the hypotenuse minus this when they're both squared. So I can simplify that to radical 1 minus x squared. Now, find the cosine. What is the cosine of theta?
It's gonna be radical 1 minus x squared over 1.
And dividing by 1 doesn't do anything. What's your final answer?
1 over radical 1 minus x squared.
Yep. And in calculus, you can leave the radical in the basement. And you're done.
That's really
A very weird but interesting formula. It doesn't have any trig functions in it at all. The derivative of inverse sine has no trig functions at all. It's 1 over radical 1 minus x squared, and that's it. Now, there are a couple implications to this. First, that was just weird. Normally we expect the derivative of sine is cosine, the derivative of cosine is negative sine, the derivative of tangent is secant squared. If you take the derivative of a trig function, you usually get another trig function, or even worse, 2 trig functions like secant. Secant tangent is the derivative. Taking the derivative of an inverse trig function seems to be a very different animal. Can anybody just take a guess?
Here we go.
The answer to that.
Inverse sine of x
It's the inverse sine of x.
plus c.
In previous times, if I had given you this problem before, like last week, none of us would have been able to do it. Substitution doesn't work. Integration by parts doesn't work. Regular rules don't work. Doomed. There's absolutely nothing we could have done. We're just like, I don't know, it doesn't have an antiderivative.
Well, it's like pulling inverse sine of x out of no way.
Mm-hmm. This we would not have known had we not explored this ahead of time. So one of the reasons I'm showing you this is that the inverse trig functions, there are 6 of them. Sine, cosine, tangent, cosecant, secant, cotangent, inverse, 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 inverse. They all have different weird formulas. The bad news is you're going to have to commit them to memory.
Oh man.
The good news is they're very closely related to each other, which helps you memorize them. I'll show you what I mean. This, go ahead and have this in your notes somewhere if you don't already. I want to try that same trick with cosine, inverse cosine. Is it possible to get the derivative of inverse cosine? I should get rid of this stuff. Well, let's try it. Y equals the inverse cosine of x. Find dy over dx. Talk me through it. It's the same procedure.
Take the cosine.
Yeah, take the cosine of both sides. So the cosine of y is equal to what? X. We have not taken a derivative, no, not yet. Now what do you do?
Then you derive them.
Now you take the derivative. Yeah. What would you get?
You get negative sine of y, or dy.
Negative sine of y dy
and dx.
equals 1 dx. The reason I put 1 dx is because we're eventually going to have to divide by dx. And I don't want to leave a gap. Keep going. I want dy over dx.
Divide by negative sine.
Yeah, divide by negative sine of y. Okay.
And dx.
And divide by dx. So these will cancel, and these will cancel, and the negatives cancel. So dy over dx equals, does that mind if I put the negative on top? Over sin y. Try it. Yeah, plug in what? Yeah, because I want the formula to have x's in it. So I want to rewrite this as -1 over sine of the inverse cosine of x. That looks like a forward-backward drawing. How do you do that?
Draw a triangle.
Draw a triangle. What kind of triangle, by the way?
Right triangle.
Right triangle. Now what?
It would be, x is the adjacent to theta, or
Yeah, put theta first, and
Yeah.
then x and, you have to make
Over
this
one.
into a fraction, so x over 1. So where's x again, I'm sorry?
x is the adjacent to theta,
Adjacent side.
and then 1 is the hypotenuse.
Good.
And the other
What's
one's the
missing side?
exact same thing.
It's radical 1 squared minus x squared. Yeah, which is 1 minus x squared. Interesting. Now, find the sine of that. So basically,
Same
this
thing,
is
it's the same thing.
sine of theta. Let's find out. So it's
Oh, it's negative,
radical
it's negative.
1 minus x squared over 1. You can ignore this. The final answer is -1 over radical 1 minus x squared. Notice something?
Yeah.
It's identical to the derivative of sine, except it's negative. If anything, it's easier than the derivative of sine. The derivative of sine is cosine, derivative of cosine is negative sine. You remember when you take the derivative of any cofunction, what happens?
Negative.
It becomes negative. And in these, it's the exact negative version of the exact other version. That can come out as very good English. But in other words, the derivative of inverse sine and the derivative of inverse cosine are absolutely identical, except the cosine is negative. I'm here to tell you that is also true for tangent, cotangent, secant, cosecant.
But I'll be negative?
So all you have to do is memorize 3 formulas instead of
Oh.
6, and then just make the other ones negative.
Easy enough.
Now, the formulas for tangent and secant are kind of exciting.
Want me to do them?
I talked you through the tangent one, but I want to do that again. Let's turbo through this. Y equals inverse tangent of x. Talk me through it.
Tangent y,
Yeah, so take the tangent of both sides.
and then
Tangent of y is equal
Derivative of each
to
side.
x. Then what?
then take the derivative of each side.
Take the derivative. What do you get?
And just what, secant squared of
Secant squared of
y,
y dy
and the dividing on each side,
equals what?
1 over,
1
oh yeah.
dx. And then what?
And then take the derivative of each side.
Oh
Oh no, we did that, then we divide.
Divide by what?
Secant squared y,
Yeah,
And
divide
dx.
both sides by secant squared of y. Okay. To cancel, and then divide by dx. So you should get dy over dx equals 1 over, and I'm going to write this a little bit strangely. Does that mean a little long way of writing secant squared?
secant y times secant y.
Yeah, secant of y, and you can just put the squared on the outside with parentheses. These are identical. Can I leave it this way? Now, what do I have to do?
Plug it.
Plug the y back in. So what is it? 1 over secant of
Tangent, inverse
tangent, yeah, inverse tangent of x, parentheses squared. How do you do this?
Oh my gosh. That's ugly, but.
Forward, backward problem. Just ignore the squared for now. Draw a triangle. Draw a right triangle, put theta anywhere you want, except the right angle, of course. Where would you put the x and the 1? What function are you using for this? For the x and the 1?
Using tangent.
Tangent.
So it'd be x is the opposite.
X the opposite,
Or the adjacent.
1 is the adjacent, correct.
Radical
How do you get this?
Same thing, usual, radical 1 plus, oh no, you have to.
You add.
Adding,
So 1 squared
plus
plus x squared, which is radical 1 plus x squared. Or x squared plus 1, take it back. So, this is theta. Can somebody find the secant of theta? What does secant mean again?
It's cos 1 over
The
cosine.
reciprocal cosine.
Oh.
What's the cosine of this?
That's hypotenuse. Oh, cosine's
Wait.
1 over hypotenuse.
So they want you to find the secant of theta. In your mind, find the cosine of theta first.
Yes.
So what's the cosine? Just the cosine.
1 over.
It's 1 over this radical, right?
So it's
The
just
secant.
just
So
gonna
it's just the radical.
It's the radical over 1. So it's 1 over, let's just put this in here, the radical over 1. And over 1 doesn't do anything. So we're looking at 1 over radical 1 plus x squared, parentheses, squared.
So cotangent is just a negative of that? Oh, and then the,
Cancel, cancel. 1 over, I totally agree. This is the derivative of inverse tangent.
wait, it's 1 over?
Because the original 1 over. This
Oh,
one
yeah.
disappeared, but this one did not.
Yeah.
So 1 over 1 plus x squared. We actually ran into this the other day on the worksheet that I problem number 5, I think that we threw away.
Oh.
Because we got the antiderivative of this, and we didn't know what it was. Now we do. But we can pretend that was just better. What if I asked you about this? The integral of 1 over 1 plus x squared dx, what would you say?
That's inverse cotangent.
That's inverse tangent of x plus c.
Is that on there? Is that on the worksheet or whatever?
I'm not 100% sure.
No.
This one is just derivative.
Oh, yes, it was. That's the one that was on there.
Oh, nice.
Yeah, the integration of parts.
Oh, you're gonna, yeah.
Number 5, yeah, 5.
Yeah, I think that was number 5. So again, you can sort of pretend that was a bad dream. But now it's a good dream. Because now we know what we're doing.
So now cotangent's just a negative of that?
Cotangent is just the negative version of that. Exactly. Yeah, inverse cotangent. Yeah, the derivative of inverse cotangent would be negative this. So now I'll do a summary chart in a moment. I gotta do the most exciting of the 3. Secant. This gets interesting. Y is equal to inverse secant of x. Talk me through it. Same procedure. I can't take the derivative as it is because I don't know what it is.
Secant, both sides.
Take the secant of both sides. So secant of y equals x. Good. Now what?
Derive it.
Correct. Now take the derivative. What's the derivative of secant?
That's secant.
Secant x tangent.
Oh, that's stereo. So, yeah, secant of y,
Secant y.
tangent of y, and then what's the other?
Dx.
D
X.
Y.
Oh,
dy.
oh, that's right.
Equals
Yeah.
1 dx. I want dy by itself.
Wait, dy by itself?
Divide by
Secant y.
secant tangent. Yeah, secant y, tangent y. On both sides. And then divide by dx. Cancel, cancel. I'm going to rewrite it here. dy by dx equals 1 over
Oh, man.
secant of y, tangent of y.
Plug y in that.
Yeah, we've got to plug the y back in. Where?
The y's.
2 different spots. Correct. It's going to look like this. dy by dx. Now one of them, well, I won't spoil the surprise. 1 over secant of what?
So do those cancel?
What?
Maybe.
Oh,
Maybe.
yeah. Yeah, they should.
I'm not going to tell you yet.
Inverse secant?
Secant of the inverse secant of x.
Yeah, so they.
And then the tangent of the inverse secant
So it's just x
of
left?
x.
A lot of copying.
About 10 seconds from now. Go ahead and write it down first. Yeah, okay, you've been guessing it. What's gonna happen here? Cancel. It's just gonna be x.
Sweet.
That, by the way, is pretty nice. 1 over x, and now I do need to do this. That is a forward backward problem. This was too, but it's a really stupid forward backward problem. It just went. I mean, a very nice, very polite forward backward problem that made our lives easy. Draw a triangle. Now, here's theta. Where would you put the x and the 1 so that secant makes sense? You have to kind of be a little careful on that. Secant is the backwards version, the upside down version of cosine.
So it'd be x is the hypotenuse and 1 is the adjacent?
Yeah, because normally it's adjacent over hypotenuse. This is hypotenuse over adjacent. So hypotenuse, adjacent. So what is this?
Wait, no, sorry, no.
Is it x squared minus 1?
X squared minus 1 squared. Correct. Or just x squared minus 1. So what is the tangent of that?
That would be x squared minus, or radical x squared minus 1
Radical x squared minus 1
over 1.
over 1. And the over 1 you can ignore. Final answer? 1 over x radical x squared minus 1. That's the derivative of secant, of inverse secant. Can anybody guess at the derivative of
Yeah.
inverse cosecant?
Negative.
The negative version of this.
So we have them all now?
Yes. So the three main ones, and let me put them in sort of a handy chart for you. We got this, whoops. We got the secant, blah, 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 blah. So here's a chart. The derivative of inverse sine, you tell me. You remember which one it was?
Yeah,
1 over
square root of
radical
1
1
minus
minus
x
x squared. What's the derivative of tangent inverse? These are the three basic
1
ones.
over 1 plus x.
1 over 1 plus x squared. No radical. What's the derivative of secant inverse? 1 over
x minus
X squared minus 1.
x squared.
right. A couple things to point out. Notice that the radical on the top and the radical on the bottom are in reverse order. This is 1 minus x squared in the radical. This is x squared minus 1 in the radical. That will give you different answers. This one doesn't have a radical at all, so you can swap these as much as you please. This in front, the book sometimes puts absolute values in front of the x. Don't stress about that too much. It's basically to make sure it doesn't go into imaginary land. So you can safely, I've seen books that don't do that. So I'm not going to do it. You can make sense? So you're sure, I want to give you one last problem. The chain rule is still working. So what if I did something kind of sort of heinous like this? Y equals the inverse sine of 24x to the 10. And I want du over dx. Now, the good news is, if you have these memorized, you do not have to do the forward-backward column derivation of the formula ever again, unless it's just one. It is kind of satisfying to get a formula like this, but once we have it, how do you do it? Oh, you know what I forgot? Silly me. dx, dx, dx. I forgot there wasn't prime notation. That's right. Yeah, slap a dx on the end of each of those. You see why? Yeah, because prime notation gulps the dx. So what do you think? My suggestion is kind of use substitution. Do the inverse sine of blah.
Yeah.
It's kind of like the chain rule.
So 1 over
1 over
radical 1 minus
1 minus blah,
Or blah, yeah.
yeah. By the way, I often use u on those. Squared times what?
That.
The derivative of blah. What is that?
240x to the 9th.
240x to the
9th.
9. I would just neaten this up, put that on top. A radical. 1 minus, does anybody, by the way, you do not have to simplify this, but can we do that? Anybody know 24 squared up it up there? Kind of huge.
24 squared? No.
24 times 24. Most people don't memorize their squares up that high. I looked it up earlier, so I cheated.
Is it 416?
It's bigger.
Oh, yeah.
What's really,
25 squared is 625, so it's a little less than that.
what's the? It's like 576?
Yes. 576,
How did you get that?
I wasn't sure what.
576
What he said.
x to the what?
24, 23, that's it.
Oh, that's well,
X to the
20?
20th.
20.
Got it. I'm not going to insist on you simplifying it like that. You can leave it as 24 x to the 10th parentheses squared. I'd be fine with that. Okay. But this is technically the smoothest and nicest reduction. And done. Now again, what I might do, we usually don't do substitution for derivatives. Like substitution is pretty exclusively an integral trick. But there's no reason you can't use it. People might look at you funny, but hey, if there's one thing you get used to as a math major, it's people looking at you funny. So I've kind of gotten, you know, there's a certain sort of perverse pride in that. It's y equals the inverse sine of u. So if u is equal to 24x to the 10th, what's du?
240x to the 9th.
240 x to the 9 dx. Watch what happens. Take the derivative. So dy is equal to,
You forgot dx in the end of that problem, didn't you?
which one?
That one?
This one, oh, I divided the dx.
Oh, you divided that.
Yeah, I saved myself. So dy is equal to 1 over, I'm just going to use this formula. 1 over radical 1 minus u squared du. Just plug the stuff back in. So dy is equal to what?
1 over radical 1 minus 240x to the 9th dx. Oh, wait.
24
24x.
x to the 10th squared times
240x to the 9th
Yeah.
dx.
240 x to the 9th dx. You done? I would just kick this on top and make it look nice. You do not have to use substitution for things like this. It's kind of a way to make the chain rule a little less painful. You don't have to remember, you know, don't have to hold quite so much in your head at once. Does that make sense? Okay, on your worksheet, you've got inverse secant, inverse tangent, inverse tangent, inverse cotangent, and number 5 and 6, you will need the chain rule twice.
Twice?
Yeah. It's not that bad. You can, like, look at number 5. I'll step you through number 5 on the back page. Oh, did I hand you that yet?
No.
I was like,
Wow. Okay, that would help, wouldn't it?
Number 5, let's see.
Why is nobody looking at number 5? Did I say something wrong? You just, wow. You'd like to obey, it's just physically impossible. Why can't you make a square circle? Darn it.
Yeah.
Your teacher has commanded you. Anyway, turn on the other side of page 5 for a second. Y equals the inverse, problem number 5, sorry. Second part, page. I cannot talk to you. Whatever the words I want, listen to what I mean, not what I said. So y is equal, which is another one of those dumb phrases. Do you notice it's like y equals blah squared?
Yeah.
Take the derivative.
Wow. Oh.
2 times blah, d blah. The d blah is going to be exciting. It's going to be one of these things. But you just do that as the next step. Does that make sense? So it would be kind of like 2 chain rules.
One is for the 2 times big blah to the first, times d blah.
Would that be the answer?
And then you take the d blah, which is a little more exciting, you're gonna have to do this thing.
Yeah.
Yes.
That's the answer?
And that's the answer. Yeah, and then I would just say sweep it up and make it look neat.
Okay.
Put the nice stuff on top, put the not very nice stuff on the bottom. And, that should be it. Reference it. All right, so this worksheet will be due tomorrow, and I will, send a copy home to all, and, see what happens. Call me over here, get stuck, otherwise,
See you later, Ellie.
see you later, Ella. Bye.